Hello, Legacy Sabers. Today we're going to look at translated form of linear equations. What you're going to want to have on you, your notes, the foldable I made with you in class, and then the pen or a pencil so you can write. Your learning goals: I can write an equation of a line using translated form, and I can convert translated form into slope-intercept form. So you're going to want to grab out that foldable, go ahead and find it really quick, so then we can start to write inside of it. You're going to want to open the first two tabs, these ones right here. I want to open these up. So open up those first two tabs here, and we see vertical shift up. So basically, if I ever have something added on the end, let's graph this line here. So x plus 3. Well, we're going to go up 3 on the y-axis. 1, 2, 3 right here. And then we would go up 1 over 1, right? So it's going to be a graph that looks something like that. So do you see how this graph looked like it moved from here? It moved up 3 units, right? It looked like it went up 3. So if I ever have something that's added on the outside, I can say it's going up 3 units. Same thing. X minus 3, I can go down 3 because that's your y-intercept, right? 1, 2, 3 right here. And then I'll go up 1 over 1, both sides. Like that. Notice how it went down 3 units. So this one is down 3, which is kind of cool. So this allows me to be able to graph it quickly when I have multiple ways. Now, what about this? Notice this doesn't look much different, but it's actually in parentheses. It's going to be a formality that you're going to see a little bit later here. So notice if I still graph that same line that we did before, right there, notice how this moved also to the 1, 2, 3 to the right 3. See how that moved to the right 3 as well, if you kind of look at it that way? Well, notice how, though, it was subtraction. A lot of students have a lot of trouble seeing that that is subtraction, and yet it moved to the right, because it's kind of backwards from what we think. Here's the way I like to think of it. If I plug a 3 in for this x, I'll get 0. That's how I like to think that it's going to move to the right 3. So if you have a subtraction in the inside, you're going to move right 3. What about horizontal shift left? So let's graph this line, x plus 3, move up 3, up 1 over 1, something like that. So you see how this one moved left 3, right? Kind of looks like it moved left 3. So this one's also backwards from what you think. So you see how there's a plus, you think there should be to the right 3. Well, actually, it's going to the left 3. So this is going to help us shortcut when we're finding equations of lines. It's going to be a lot easier for us to find a point somewhere out in the area and being able to flip it and being able to move it really quick. Now, there's a few other ways. Vertical stretch, so 3x. So we already know that. It's going to start at 0, 0, and go up 3, 1, 2, 3 over 1. 3 over 1. Something like that. Notice how it looks like I basically took the ends of my linear equation and I went and stretched it. That's what that allows you to do. So it changes your slope when you have something out there and stretches the equation out. Pretty much that's all it does. Okay, you've seen kind of slope do that for a while. 1/3 then, if I go up 1 over 3, basically all it does is it basically compresses it, or basically pushes it down, so it's a nice, not as steep of a line, right? So it's going to look something like this. So you notice how it basically kind of looks like something pushed on the top and the bottom just pushed it down. So this changes your slope again to whatever the number is. And basically it compresses the graph. And then you guys also know when there's a negative outside, so that would be going, this would be this line going like this. It's a negative slope, right? So basically it flips the line across. Flips it down. So let's look at this one. So this is kind of a little different. Let's think of it this way. So let's look at these parts here. So we know that -1, if you look back, that's meant that it was going to go right 1 from the axis right here, right? So I'm going to go right 1, and then that -2 on the outside meant going down 2. So I'm going to go down 2. 1, 2. Right there. Now what I can do is go up 2 over 1. And I'll graph my new line. And it's going to look something like this. Now you're probably saying, why is this helpful? Well, it actually is. It's going to allow you to create equations of a line based on certain criteria, so you don't have to solve for b. It's not going to be as hard to create an equation, because all you need to do is think, okay, how that point changed from 0, 0. That's what you're going to have to do. Then you can also graph from any point using slope to make your line. Sometimes you're going to have to go off graph for a y-intercept. What this is going to allow you to do is not have to go off graph as bad. Let's try a few examples so we can kind of see how it goes. So I need to write the equation of the line that goes through the point 3, -5 and has a slope of 3. So I am always going to want to think of this following form. My slope x minus h plus k. Okay? So h is how did it move left or right? And k is how did it go up or down? So at this point, we moved right 3 and down 5. So that's what we're going to want to think here. Think of that as an ordered pair from 0, 0. You're going to move right 3 when you would graph it, and you'd go down 5 to graph it, right? So my slope is 3, so I'm going to put that there. Put my parentheses, x. Now, it's a 3, a positive 3, and I'm going to move right 3, right? But remember, on that foldable, when our line looked like he moved right 3, it was actually subtract 3 in the parentheses, right? Go ahead and take a look back at your foldable and make sure I'm right. Whenever we moved to the right 3, it actually was subtract the number. So I'm actually going to subtract 3. Then I'm going to go down 5. So I'm going to say down 5. This is actually done. This equation is actually done. It's actually the same one that you would have gotten if you would have done y equals mx plus b. It's just in a different form. And you're going to notice that some of these, it's going to be 10 times easier to do these when they're in this form than y equals mx plus b, because you're going to get fractions. You're going to get really icky, gross numbers. These aren't going to prevent you from getting so much fractions. Let's try this next one here. So I know I'm going to have f of x that goes through the point -4, 2 and a slope of 1/2. So my slope is going to sit outside those parentheses there. This -4, so that's, if I would graph that point, it'd be left 4 up 2, right, to graph that point. So I'm going to think left 4. Well, it's not going to be -4, because remember, in the parentheses, it's backwards from what we think it should be. So since I move left, I'm actually going to add 4 on. Then I'm going to go up 2, so I'm going to say up 2, because remember, up and down is what you think it should go. Okay? That is the equation of my line. It is done. It could be simplified, and we'll do that on our next slide here, but that is actually a done equation. Let's keep trying. So I got this equation. It goes through these 2 points. Just like before, you need to find the slope of those 2 points. So I'm going to keep in my mind, I got to use this slope formula. Make sure you go y's over x's if you've been having a little trouble with that. So we're going to go 5 minus 4 over 2 minus 6. So I go 5 minus 4, I get a 1. 2 minus 6 is a negative 4. So I know my slope is negative 1/4. Gross, right? We're going to get some decimals and fractions and bleh. Well, we're not going to have to do that because we're going to use our translated form. All I need to do is take that slope. So I'm going to have f of x equals negative 1/4. Now, you can pick either of these 2 points. Doesn't really matter. Let's do 2, 5. So this moved right 2, up 5. So right 2 would be subtract 2 in the parentheses, and then up 5 would be on the outside. Now, I need to convert this equation into slope-intercept form, because if you want to ever graph it on a graphing calculator, you actually need to have it in slope-intercept form. So let's go ahead and graph. Let's go ahead and change this. To change it, all you have to do is multiply that negative 1/4 in. Not too bad. So negative 1/4 times x is just negative 1/4 x. Negative 1/4 times negative 2 quick is a half, because 2/4 make 50 cents, right? And then I still have this plus 5 kind of hanging out here. So let's simplify. I still have 1/4 x, but a half plus 5 is 5 1/2. I'm done. That's my equation. Imagine getting that if we did solving for b. We would have had to got to be a 5 1/2. That would have been totally gross. This was a lot easier, not as much solving, more just simple math that we can use our calculator for. Let's try this one. So I got write an equation of a graph that goes through the point 3, 6 and negative 9, 2. So, and then we got converted into slope-intercept form. Let us use this formula. So I got 6 minus 2 over 3 minus negative 9. So 6 minus 2 is 4. Change that to plus. I get 12. So that's 1/3 slope, right? Think I did that right? So then let's plug into our formula here. F of x equals 1/3. What equation should I use, or what dot? Should I use this dot or this dot? I'm going to use negative 9, 2. So that would be, I move left 9, up 2. So left 9, remember, it's going to be opposite of what you think. So it's going to be plus 9. And then I moved up 2, so that's plus 2. Let's simplify this. I got to get this into slope-intercept form. So basically, slope and a number, not this parentheses stuff. So let's distribute the 1/3 in. 1/3 x plus 1/3 of 9. That's 3. So my equation, if I add these two together, 1/3 x plus 5. Pretty easy. Let's try example 3 here. So find the equation and then graph it that fits the following using translating form. So we're going to want to make sure that we can graph this. But it's going to be kind of gross. It's going to have a y-intercept. So let's go ahead and graph first. So I'm going to start at negative 2 and 8, right here. And I have a slope of 5. That's going to go off graph. But let's go this way. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. It's going to be a line like that, right? Whoops, a little wavy. That's okay. Now, notice you can't get the y-intercept right there. You're going to have to guess. You're going to have to extend your line. It's going to be forever to do that. Let's use translated form. So I'm going to go f of x equals, my slope is 5. Then we need to do something with x. So x moved left 2, up 8. So left 2, well, left 2, that would be plus 2 inside the parentheses, right? Because we move left 2, and then plus 8. Let's get into y equals form. So distribute my 5 in, we'll get 5x plus 10 plus 8, or 5x plus 18. Imagine trying to figure out that y-intercept from my graph. Whew, that would have been hard. But with translated form, it allows us to be able to get strange y-intercepts and also graph when there is really large y-intercepts. And that's the end of this video. See you later, Sabers!